All right, this next Paigecast is going to deal with changes in the states of matter between solid, liquid, and gas. And I've got a display back here that I'm going to show it work from here. And here we see that we have our solids, our liquids, and our gases right here. Now, solid we know has a nice definite volume, definite shape. Notice how they're arranged nice and neatly there. The molecules there. And a liquid has a definite shape or a definite volume, but not a definite shape. And we can see they're moving a little bit. Gas, we know, no shape, no volume, just bounces everywhere. All right. Now, as I add heat, all right, I take my solid, as I add heat to it, add heat energy, it's going to melt. It's going to break those attractions between those molecules, and we're going to change to a liquid. If I continue to add heat, the bonds that are holding those molecules together, they're going to get going faster and faster, and it's going to evaporate to a gas. All right. Now, let's go the other way. Let's say I take heat away from it. Let's start with a gas, all right? I start to take energy away from it. Those molecules are going to move slower and slower, and they're going to form a liquid. We call that condensation. If I continue to remove heat from that liquid, it's going to change from a liquid to a solid. We call that the process of freezing, all right? So there we have, from a solid, liquid, gas, as I add heat, melting and evaporation. As I take heat away from a gas, condenses to a liquid, liquid freezes to a solid. All right. Now, two other concepts we have to talk about here, I'm going to throw out at you, is heat of fusion and heat of vaporization. All right. Let's start with that first one, heat of fusion. Okay. Right here, I see this line that separates my solid and my liquid. All right. Imagine I have a chunk of ice sitting on the table, and I start to heat it up. Okay. I add heat to it. Eventually, it's going to get to 0 degrees Celsius. Does it automatically all melt at once? No. What happens is it's going to take energy to change it from a solid to a liquid. When I add energy, the temperature goes up until I get to 0 degrees Celsius. All right? And then it's going to continue to add energy, taking the energy, and melt. Now, that's the heat of fusion. How much heat energy does it take to melt it? Okay? Now, it's a liquid. All right? I got a pan of water on the stove at, say, and it's boiling. At 100 degrees Celsius, does it instantaneously vaporize? No. All right? It takes a long time to do that. I have 100-degree water and 100-degree steam. So the heat of vaporization is how much energy do I have to add to change it from a liquid to a gas. The heat of fusion is how much energy do I have to take away or add to change from a solid to a liquid or a liquid to a solid, vice versa. So there we have melting, evaporation, condensation, freezing, heat of fusion, heat of vaporization.